Hi, so today I'm going to be doing something a little different. As some of you know, I'm one of the top answers of questions on Quora related to APIs, RESTful, and things of that nature. And I tend to see a lot of redundant questions on APIs. And I've come to learn that people in general just don't know what APIs are and how they work and what they do, what an endpoint is, and so on and so forth. So I thought I'd take a little time today to do a Q&A on APIs and just generally answer some basic questions and some complex questions as to what APIs are and some of the more general questions that I see that should be able to be answered, but I see so many engineers and CTOs completely unable to answer these, which I find bizarre. So, without further ado, let's just go into some of these real quick. So, what is an API? Well, API actually stands for API Programming Interface. And a lot of newbies will just say, well, an API is for connecting to your database. And this is incorrect. Java libraries have APIs. C libraries have APIs. They don't connect to your database whatsoever. Android SDK has APIs. The API can be considered more like a standardized communication interface. And what does that mean? Well, an interface can be considered like the little circular things on a Lego. They help to bring those two Legos together. It's a way of bringing two things together. And a communication interface is a way of communicating between two things. So a standardized communication interface is a standardized way of communicating between two things, which is why I say an API is a standardized communication interface. And in this case, we will be talking about web APIs, which use the HTTP and HTTPS protocol. Not so much programming APIs, which don't use HTTP and HTTPS. We'll be talking about web APIs. Does RPC use REST, and which is better, RPC, remote procedure call, or RESTful? Yes, RPC uses REST. There's no other way to communicate over HTTP and HTTPS. You will be doing a get, put, post, or delete regardless. Most people, when asking this question, which is better, RPC or REST, they actually mean which is better, RPC or RESTful, which is the next question. They're actually two very distinct ways of doing things. Now, RESTful, what you're effectively doing is you're making every single controller where the business logic lies for the API call, you're limiting it to a CRUD-based system, which is create, read, update, and delete, so that those four functions map to the four REST calls: get, put, post, and delete. And that's what you're limited to, period. So that you can map more easily to the URL. And it's an intuitive mapping without having to look at the API docs every single time to see what you're supposed to call. That's what they're going for, so that it can be more intuitive, so that it's easier to program, so that it's supposedly easier to automate. However, this makes it harder to develop for because it's very, very limiting for your business logic. RPC, on the other hand, allows for unlimited calls per your controller. It's more flexible for your business logic. And as a result, more enterprises tend to lean more into RPC. Startups tend to lean into RESTful and then move into RPC. And enterprises tend to all drift into RPC because they have more business logic and they need to just be able to do things. They're not worried about the intuitive nature of their URLs. Which is better? Honestly, my saying is always plan for 5 years of development. And I don't like to rewrite code. I would say never ever rewrite your code if you possibly can. Plan for 5 years out. If you think that you're going to be moving quickly in your business, go with RPC. If you think that your growth rate is very, very slow, okay, rest is what you'll need. What is the difference between URI, URL, and URN, and which is completely unnecessary for an API call? Which is most important for routing the call from client to API server, and which is most important for processing the API call? What is the difference between URI, URL, and URN? The URL is basically everything in the URL bar. The URI is the path on, and the URN is the very last element on the path. Which do you need for routing the API call? You need the URI. The URI tells you exactly how to route that API call. Which don't you need is the URN. The URN is effectively useless. The URN is used by the front end. It's effectively index.html or index.php or page.html. It's what tells you how to render the view, the UI, the UX. Now, your API server is not concerned with the view. It's concerned with returning data for the requesting view, the page that is requesting this data. So the URN is useless. We're mainly concerned with the URI. The DNS is concerned with the URL so that it can route to your API server. The API server is mainly concerned with the URI. What is the difference between content type and the accept header? And do we need both when sending? So content type and accept. Content type is what tells us the data coming in, and accept tells us the data coming back to the client. So in 90% of cases, the content type coming in, so if it's JSON coming in, 90% of cases, they want JSON coming out. Only in the freak cases will we get JSON coming in and they will say, I want this back as XML, or I want this back as PDF. In that case, I would say build an exception. Build an exception for this one case, build an exception for, or build that as a separate API endpoint or something. 90% of cases you should only be sending the content type. Except sending an extra header is extra overhead for your API servers. If you have a couple 100,000 people sending that data and you having to process the data into a separate format, or even trying to do all those checks and everything, that's extra processing and everything that you don't have to do if 90% of the case it's the same format. I would just say assume it unless you have a specific function that requires it to not be. And then just build that function. And just don't accept header. Just build the function that's supposed to do that. What is CORS, cross-origin resource sharing, and why is it important? Does it block curl requests? CORS. So cross-origin resource sharing is a way to whitelist UI UX front ends. So say for instance I have a Node.js server that's calling my API backend to get data. We don't want other people, third parties, to be calling my API server, even though I've given them a key, a user a key. I don't want them to put that key into an API, into a Node.js server, and then now call my API backend and use it as a server. I'm like, no, that's not what that key is for. So I whitelist specific servers. This is what CORS is about. You whitelist specific servers to call your backend and say, these servers can call my backend. Users can call the backend via curl and things like that. This doesn't block server-to-server calls. It just blocks application. Sorry about that. It just blocks application calls. So you're limiting which applications can call your backend, so to speak. Where's the load balancer in the architecture? And is that a hardware or software load balancer? So load balancing can get a little tricky. You can go, a lot of proxies, API gateways, build load balancers right in. And this is what's known as a software load balancer. It's not a hardware load balancer. Hardware load balancers are very robust, very fast, but they're also very expensive. And people will tend to use these when they're at like hundreds of servers because they're so expensive. Up until then, they'll use software load balancers, like Amazon's API Gateway, total software load balancer. But in front of that, they'll put a hardware load balancer. So hardware load balancers will go in front of API gateways, which will then have a software load balancer on them. Otherwise, it's just a software load balancer as the API gateways, how most people do it. Do you need a gateway or proxy, and why? Could you do that locally? Could you do most of that functionality locally at the API server? Why or why not? Now, do you need a gateway or proxy? So, this was a conversation that I had with an Nginx architect. If you properly implement the API pattern with the data abstracted from functionality, no, you don't need a API gateway. The API gateway is only needed mainly because you have to handle the redirect from the API pattern in your API server. So every single time you do a redirect from your API server, it has to go back out, check the DNS of where it needs to be routed, come back into your load balancer and or your API gateway, and then come back in. And as a result of this, your threads get dropped and recreated. Your sessions have to be reissued and come back in, and there's a lot of I/O overhead. There's a lot of threads being hung and waiting to be cleaned up and stuff, and it's just a mess. But if you can do that with a forward rather than a redirect, you save a lot of time, and it's internalized. And once it's internalized, you can keep everything inside. And besides, most of these architectures already can do forwards, and as a result of that, you have to do some internal security and everything. Thus, the proxy or the gateway is redundant in a lot of cases. The caching has to be localized, the security has to be localized. A lot of things that the gateway is doing, the API server is doing too. So it's a lot of redundancy both at the API server and the load balancer. So everything that you have at the API gateway is redundant. And I pointed this out to the Nginx architect, and he was like, yeah, it's true. You don't need it. I'm like, so why? He was just like, well, some people, when they're starting out, they find it's easier to just do this. I'm like, so there's no point. He's like, yeah, no, it's each to their own. I'm like, all right, whatever. So how is your API redirect routed? Can this be done better? If so, how? How is an API redirect routed? Well, I think I just answered that indirectly. A redirect, anytime a redirect happens at the API server, it goes outside the API server, it drops a thread, goes outside the API server, the DNS gets picked up. I mean, it should get picked up inside the local network and get redirected back to the load balancer or API gateway and back to the API server where it recreates its thread and picks everything back up. But yeah, there is that I/O overhead of going out and coming back in, drop threads and everything. So that's it. And I hope you enjoyed that. Keep watching. I'll be posting one of these hopefully every week. Take care.